What exists in the multiverse beyond our visible universe? Is it possible that our universe is just one part of a larger multiverse? Humanity's ideas about alternative realities are ancient and diverse. In 1848, Edgar Allan Poe wrote a prose poem in which he imagined the existence of inheriting the boundless universe. But the concept of multiple worlds really began when modern scientific theories attempt to explain properties of the universe that predict the existence of other universes, a place that takes place outside of our reality. Our understanding of reality is still incomplete, says André Linde, a physicist at Stanford University. Truth still exists independently of us. These universes will be separated from our universe, unable to reach and cannot be detected by any direct measurement, at least until now, and that has some experts questioning whether can multiverse be called true science. Will scientists know that our universe is only one universe? We break down the theories about possible multiverses, which includes other universes, with the laws of physics in each place. And your version of the story may well be there too. What is the multiverse? Multiverse is a term scientists use to describe the idea that beyond our observable universe, other universes may exist as well, predicted by many scientific theories that explain various possible situations, from areas of space in different planes, from the universe of us, to the division of the bubble universe that continually pops up, bubble universe. One thing these theories have in common is that the space and time we observe are not the only realities. So why do scientists think there might be more than one universe? We can't explain all the features of the universe if we're just one of them, says Tom Siegfried, a science journalist whose book The Number of the Heavens explores how multiverses have evolved over thousands of years. Why constant? So is nature's standard, Siegfried wondered. Why was there enough time for our universe to form stars and planets? Why do stars shine the way they do, with just the right amount of energy? These are questions that are not answered in our physical theories. Siegfried said, there are two possible explanations. First, we need newer, better theories to explain the properties of our universe. Or is it possible that we are just one of many, universe which is different, and we live in a good and comfortable universe? Perhaps the most scientifically accepted idea comes from something called the inflationary cosmology, which is the idea that in a short period of time, after the Big Bang, the universe is expanding at an exponential rate. Cosmic inflation explains many observable properties of the universe, such as the structure and distribution of galaxies. This theory, at first, seems like science fiction, although it is a very fanciful theory, says Linde, one of the founders of the theory of cosmic inflation. But it explains interesting aspects of the world in a way that people take more seriously. One of the theoretical predictions is, swelling can occur over and over again. Maybe there's no end, forming a constellation of cosmic bubbles. Not all of these bubbles have the same properties. There may be distances that cause different physical behavior. Some parts may be similar to our universe, but all of this is beyond our scope, can be directly observed. Another interesting type of multiverse theory is called parallel worlds in quantum. It is a theory that explains mathematically how matter behaves. Proposed in 1957 by physicist Hugh Everett, quantum parallel worlds predict the existence of branching timelines, or an alternate reality that has some form. They vary, sometimes producing very different results. So where are those other worlds? Those worlds overlap in dimensions that we cannot access. Max Tegmark of MIT describes this type of multiverse as level 3, where situations it will occur in different realities. The multiple universes predicted by theories about cosmic inflation are what Tegmark calls multiple universes. That level 2, which may have basic physics laws that vary according to each universe. In the multiverse of inflation, Linde said, You don't even know. In some parts of the universe, an explosion is even possible in principle. If we want to find ourselves in another world, what must we do? Can we travel between worlds? Unfortunately, it probably won't. Scientists didn't think it would be possible to travel across the universe, or at least not yet. Except that a lot of the laws of physics that we know might not yet be correct, so we can't go to other multiverses yet. Siegfried said, "But who knows? 1,000 years from now, maybe someone has thought of something we never imagined. Although there is some evidence of a universe that appears to have other universes, but there is nothing to suggest that they exist. Until now, the evidence supporting the idea of multiverses is purely theoretical and in some cases, philosophical. Some experts argue that it may be a grand coincidence that the Big Bang gave rise to the perfect universe we have. Other scientists think it is more likely that there could be any number of other universes. We just live in a universe that suits our way of life. There are still scientists who argue that, is multiverse a verifiable theory? Some might say no, by the definition that the multiverse is independent of our universe and unable to reach. But perhaps we are the ones who may not have thought of the correct test. Will we know that? Is our universe just one of many? We may not know. But multiverses are one prediction of many theories that can be tested in other ways. And if those theories pass all the tests, multiverses may still exist too. Or perhaps some new discovery will help scientists figure out, there's something. Is it really beyond the universe we can observe? We can say that these things cannot be tested and therefore are not true, but that might mean we don't yet know how to test it, and maybe someday we may or may not find a way to test it. But this universe can be anything. U.S. Oak Ridge National Laboratory experiments are about to begin to prove the existence of parallel universes and search for channels that open the door to such a universe. It may be similar in every way to our universe, like a mirror image, said Dr. Leah Broussard, lead physicist on the project. With the NBC television station that, even though this experiment sounds bizarre, it's like science fiction, but their team wanted to test the possibility. In the matter of the fundamental particle of an atom, such as the neutron, should be able to travel back and forth between our universe and parallel universes. The Big Expansion Explosion, or Big Bang event 14 billion years ago, besides giving birth to our universe or universe, it also gave birth to the multiverse, which is an infinite number of universes other than our own, which is sometimes called parallel universes. In the multiverse may have dual universes, parallel with the same elements as in our twin universe. For example, there are elementary particles, stars, or even living things, and each human being is the same. It's like a reflection in a mirror. However, events occurring in parallel universes are likely to be infinitely different from our universe. Previously, there were many scientific phenomena that could not be explained. These phenomena point to the possibility that parallel universes actually exist. For example, our universe contains less of the isotope lithium-7 than would have been expected after the Big Bang. Or in the case of high-energy cosmic rays traveling from outside galaxies that were found to be too powerful to travel within the bounds of the observable universe. In the 1990s, experiments were conducted to time the time it took for neutrons to decay into protons, after a neutron is removed from the atomic nucleus, but the results after that were not as expected. When it was found that the time spent by neutrons in not all decays are equal, scientists cannot explain this phenomenon unless some neutrons stray into a parallel universe and become particles in another universe for a moment, before reappearing in our universe again. The latest experiment in which a team of US physicists will start moving forward this month. It uses a beam of neutron particles to hit a wall that prevents them from passing through. a neutron detector will be installed behind the wall. Normally, the neutron detector in this experiment would have returned 0. That is, no neutrons were found, can pass through walls. But if there is an unusual case where neutrons are found to escape through, it may be evidence that the particle vibrates enough to cross the line between universes, can pass through a parallel universe and come back out. The team will also install a powerful magnetic field on either side of the wall, trial each time, and the strength of the magnetic field will be adjusted to vary at many levels because it is expected that this may be an important factor that allows neutrons to oscillate and be able to cross to other universes. However, Dr. Broussard said he did not expect to encounter a phenomenon that would immediately open the door to a parallel universe this time, and it is expected that the results of the detection of strange behavior of neutrons will be 0. But if something new is discovered like that, the face of physics will change completely, said Dr. Broussard. And Hawking's final theory points out that multiverses have the same physics laws as in our universe. The Journal of High Energy Physics has published a research article that is the final work of the late Professor Stephen Hawking. Professor Hawking and the Belgian physicist revealed of the new theory that they jointly invented about multiple worlds, multiverse. Professor Thomas Hertog from Belgian Catholic University of Louvain. The co-authors of the research article stated that the new theory is the result of his and Professor Hawking's joint effort spanning 20 years to solve problems arising from theories about the origins of the universe and multiple worlds, which Professor Hawking proposed in the 1980s together with Professor James Hartley, an American physicist. The original theory of Professor Hawking and Professor Hartley used the principles of quantum mechanics to explain the universe, or how the universe we live in came into existence from nothing. They also point out that the Big Explosion, or Big Bang 14 billion years ago, also gave birth to many universes, which is an infinite number of universes other than our own. In the multiverse, there are other universes where the environment and events occur just like in our universe, including a universe with countless different conditions and possibilities of events, which is sometimes called parallel universes, such as today the dinosaurs have disappeared from the world, but in another universe, large herds of dinosaurs might still dominate the Earth. You can stay. The original theory of Professor Hawking pointed out that there are an infinite number of possible universes, and each universe has its own unique set of laws of physics. This raises the problem that all kinds of natural laws can occur in countless numbers across multiple universes, until it is impossible to know what principles our own universe is governed by. This is equivalent to the collapse of science. Professor Hertog revealed that Professor Hawking was extremely dissatisfied with the conclusion of this original theory, and solved it using mathematical techniques developed to study string theory. Let's improve this concept, until it was discovered that there was a theoretical possibility that the multiverse would have more order than that. A new theory developed by Professor Hawking and Professor Hertog points to multiple worlds. It consists of universes that are similar to our universe. It has the same physical laws as well. This idea will help scientists find traces of evidence confirming the existence of parallel universes. From gravitational waves and cosmic microwave background radiation, the laws of physics that we know and test in laboratories today. It is a natural law that does not exist forever, but it only came about when the universe expanded and cooled after the Big Bang. This rule depends greatly on the physical conditions at the time of the large explosion. We hope that this study will lead to a better understanding of where do the laws of physics come from, and is it unique to our universe, Professor Hertog said. If you like space stories, you are our friend. Click follow and press the bell so you don't miss any action.